I've got two questions which says find the terms independent of x for the following expressions. Well, we first have to identify, so let's answer part one. Okay, we first need to identify our a is actually x, our b is actually 1 over x, and our n is what? 4. Our r we don't know. You can call it r, m, k, it doesn't matter. Then let me call it k. Oh, it's okay, there's no problem. Then we are going to use the binomial theorem, which says that n factorial you divide by n minus r factorial, then r factorial multiplied by what? A to the power n minus r multiplied b to the power r. That's a binomial theorem, right? So we just have to plug in. Now remember that this part here, it will be the same because we don't know the value of r. But we know what n is. We know what n is, minus r factorial, then r factorial multiplied by a is x, but x to the power n is 4 minus r. b is 1 over x to the power r. We cannot evaluate this part, so let's just keep it constant, right? Multiplied by this part here, all right? This part here is the same as, you would agree that this is just x to the power. Right, so then this will be 4 minus r. We are multiplying the same one by 1 over this, the power what? R. So this will be x to the power 4 minus r. We are multiplying this. Now, when you reciprocate this one, you are just going to get x to the power negative r, because 1 over x, yeah, it's just x to the power negative 1. Then the powers will multiply each other like that. From the indices, these are the same bases, so we just add the powers. So we have x to the power 4 minus r minus r. Remember that we are keeping this part here constant, right? All right. So we proceed this side. So I'm keeping the same. We are multiplying by. And here what we have? We have x to the power 4 minus 2r. Now remember they are saying independent term of x. Now, independent term of x, the following condition must apply. It just where x is equal to the power 0. This should be equated to what you found here. So we're just going to equate x minus, like that, equal to x to the power 0. Then we're just going to equate the powers because they're the same bases. So this will be 4 minus 2r equal to 0. And this will be 2r equal to 4. And our r is 2. Now that we know the value of r, we can now, remember, if we try to replace back here r here, it will give us 0, right? That's why it's an independent. So we just have to work out this part here. All right, which we are going to do in this. So remember, it's 4 factorial. You divide by 4 minus r is 2 factorial, then multiply by 2 factorial. This will give us 4 factorial. You divide by 2 factorial and 2 factorial. All right, so from factorial, you know that 4 factorial, I can get 2 factorial and 4 factorial. I work them out, and I remain with the other 2 factorial, which will just give me 3 times 4 there on top and 2 factorial here, and this will give me what? 6. Therefore, the independent term of x, the independent term of x in the expansion of x plus 1 over x to the power 4 is 6. we didn't find anything here that we could have replaced r again. No, everything was just giving us a 0. Let's go to question number 2, which says x squared minus 2x minus 2 over x to the power 6. Can we do that? So we have x squared minus 2, you divide by x to the power 6. In this case, our a is x squared, our b is negative 2 over x, our n is 6. We are going to apply the same formula. N factorial, you divide by n minus r factorial, then r factorial, multiplied by a to the power minus r times b to the power what? R, like that. So we now just plug in. N is 6 factorial, 6 minus r factorial, then r factorial. We multiply by what is a? A is x squared, so it will be x squared to the power n is 6 minus r. Multiply what is b? B is negative 2 over x, but to the power r. This part will be kept as usual because we are still evaluating what is on the right side. So I'll use the same one. So this, okay, the powers 2 and these will multiply each other. Remember, powers will multiply each other. This will give us x to the power 12 minus 2r. We are multiplying by. Now let's write this one in the way it's supposed to be. This is the same as negative 2x to the power negative 1 to the power r. I've just reciprocated this one here. Now this r here is multiplying everything inside here. That means we have x to the power 12 minus 2r multiplying by. So I can now branch this part here. This will be negative 2. Remember I said it's multiplying everything to the power r, and the x negative 1 to the power r. That's what it means. So here we have x to the power 12 minus 2r multiplied by. Here, I'll keep this one away. I'm only interested in x. So I'll bring my x here. Now negative 1 and r, they are all powers, so they can multiply each other, and this will give us negative r multiplied by negative 2 to the power r. This one is not that important. We are interested in this part here. Therefore, we are dealing with this expression of this form. 6 factorial, you divide by 6 minus r factorial, then r factorial, multiplied by negative 2 to the power r, multiplied by. Now these are the same bases, right? We're going to add the powers. This will be x. 12 minus r minus, so 12 minus 2r again minus r will give us 12 minus 3r. And this is the part we are going to equate to 0. So we are saying for independent term of x, x to the power 0 is equal to x to the power 12 minus 3r. So this is 0 equal to 12 minus 3r. And the 3r is equal to 12. And my r, sorry. And my r is just equal to 4. Now that I know the value of r, remember, there's a part here which is remaining. It's not that whatever he is here will give us is 0 or something. No. When I just replace 4 there, this will be x to the power 0, which is 1. 1 times everything should give me what is on the left side, right? Let's go now. So on the left side, we have 6 factorial multiplied by 6 minus r factorial, then r factorial times negative 2 to the power r. What here, it will just give us 1. Remember, x to the power this and this to be 0 to the power that. So if you want, you can include it just 1. There's no problem. But this will be 6 factorial. You divide by 6 minus 4. Okay. Factorial, then 4 factorial. Multiply by negative 2 to the power 4. That is r. 1 can remain. So just 1. All right. So this will be 6 factorial. You divide by 2 factorial. Multiply by 4 factorial. Multiply by. This will give us 16. We can evaluate 6 factorial and 4 factorial. What do we get? We get 5 times 6 as usual, and over 2 factorial times 16. Now 2 factorial is just 2. And this will give us 5 times 6, 2 times 16. 2 can go there. 8. It will be 5 times 6 times 8. That is 30 times 8, and this will give me 240. You conclude. Therefore, the independent term of x, all right, the independent term of x, okay, term of x in the expansion of x squared minus 2 over x to the power 6 is 240. You're done.